Hello students, today we will learn about the inversions of double slider and crank chain. So we have already seen the inversion of a single slider and crank chain. Now we will see about double slider and crank chain. Among that, the first one which we will learn, the first inversion is the Scotch Yoke mechanism. The first inversion is obtained by fixing the link 1. So this is the link 1 and it is fixed. The first inversion is obtained by fixing the link 1. So by doing so, a mechanism called Scotch yoke is obtained by fixing link 1 SCOTCH Scotch yoke mechanism is obtained. The link 1 is a slider and even the link 3 is also a slider. So link 1 is a slider similar to link 3. Link 2 works as a crank. So here you can see link 2 is here and this works as a crank. So this is the link 2 which is working as a crank. Is working as a crank. Then link 4 is also a slotted link. So here you can see link 4 is a slotted link. Link 4 is a slotted link. So when this link 2 that is acting as a crank rotates, then this link 4 simply it will have a simple harmonic motion for angle theta of link 2. So when this link 2 rotates by an angle theta, then this link 4 will have a simple harmonic motion. When link 2 rotates, link 4 has simple harmonic motion for angle theta of link 2. So this is about the Scotch yoke mechanism. The next type of mechanism in this double slider and crank is the Oldham's coupling. The second one is the Oldham's coupling. So in this case, link 2 is fixed and this mechanism which is obtained is called as the Oldham's coupling. Here link 2 is fixed. So you can see this link 2 is fixed, which is symbolized here. This coupling is used to connect two shafts which have eccentricity. So Oldham's coupling is used to link two shafts which have eccentricity. So the axes of two shafts are parallel but displaced by a distance. So here you can see the two shafts, that is, this is S1, that is shaft 1, and this is S2, shaft 2. You can see the axes of these two shafts are parallel but they are placed at some distance. Two shafts are parallel but displaced by distance. The link 4 slides in two slots provided in link 3 and link 1. So this link 4 slides in two slots which is provided in link 3, which is here. So here you can see there is slot here, and even here there is a slot in the link 1. So in these two slots this link 4 will slide. The link 4 slides in two slots provided in link 1 and link 3. The center of this link will move on a circle with diameter equal to eccentricity. Of this link will move on a circle with diameter equal to eccentricity. So this is about the Oldham's coupling. The next type of inversion of a double slider and crank chain is the elliptical trammel. So this inversion is obtained by fixing the link 4. So this inversion is obtained by fixing the link 4. So the mechanism obtained by fixing the link 4 is called as the elliptical trammel, which is shown in the figure. So this mechanism is used to draw ellipse. So to draw an ellipse, this type of mechanism will be used. So this mechanism is used to draw ellipse. The link 1, which is a slider, moves in a horizontal slot of fixed link 4. So here you can see the link 1 which is shown here. Okay, this link 1 moves in a horizontal slot of this fixed link 4. Link 1, which is a slider, moves in a horizontal slot of fixed link 4. The link 3 is also a slider, moves in a vertical slot. So this link 3 is also a slider, it moves in a vertical slot. Link 3 is also a slider, it moves in vertical slot. Then there is a point D. So you can see a point D here on the extended portion of link 2. So this point D is on the extended portion of link 2, which is mentioned here. So this is link 2 and the extended portion is marked with a point D. It will trace the ellipse with the system of axes which is shown in the figure. So this point D will trace the ellipse with the system of axes. So here you can see there is a system of axis x and y in all the 4 directions. So this point D will trace the ellipse along the system of these axes. So this elliptical trammel, as the name indicates, is used to draw an ellipse. The point D on the extended portion of link 2 traces ellipse with the system of axes as shown in the figure. So this is all about the inversion of double slider and crank. So there are 3 different types of inversions which we have studied. I hope you have understood the difference between these inversions and what they are actually meant to do. Thank you.